Good afternoon, everyone. Today we're going to continue our discussion on Introduction to Time Series. I I gave you a file, a text file. May I request you to please make sure that it's inside the our project on time series analysis project. And then may I request you to open this, click this here under the files uh, window. If we click this, then it will open in an R script window. I'm going to close this because I don't save. Okay, so we have this. This is the text file that we're going to work on. I'll explain in a while what we're going to do with this. Okay, and let's open an RMD file, R Markdown file, R Markdown. Okay, we can title it Introduction to Time Series. Okay, I'll just give it a date, January 17, 2025. You can name it any way you want, of course. I'll just make it use current date when rendering document. Okay, it's a document, HTML, then okay. So it will open the default RMD file. Let's delete this. Let's delete the template, the default contents, and let's copy the one that I shared with you. Okay, Control C, copy it here to our R Markdown file. Control V. Okay, and then I'm going to close this because we don't need this. I don't need this. Okay, so that there's only one file here. Okay. You may wish to save this file. Okay, so maybe I'll copy this. Control C, and then File, Save As. So it will save automatically in the project. Control V, and then I'll just name it 1. Okay, or I can name it January 17, 2025. Okay, so that I know that this is the RMD file that we use on January 17. Next meeting, we'll be continuing to work on this. Then you can create another file, January, let's say 22. Okay, save natin. All right. By the way, before I continue, on Tuesday, I'm not sure if we'll be able to meet face to face, but definitely we'll meet. If I'm not yet okay to travel, then we'll just meet online next meeting. But definitely we'll meet, whether it's face to face or online. It will depend on the instructions of the doctor. So please bear with me. I'm sorry for the inconvenience this might be causing you. Hopefully that will be the last online meeting on a Tuesday that we'll have. All right. So you'll notice that this file has several CCs there. We're going to erase that later on. What I did was it just tells us that there's a code chunk here. So whenever you see that CC, we're going to insert a code chunk there. So that's why you have here several CCs. Okay, so that's what that means. All right, so let me close the outline. The title of our discussion for today is Introduction to Time Series. We started with this last meeting, but let's have a brief review of what we have discussed so far. So the importance of time series analysis is that we analyze time series in order to forecast future trends. So this is especially of particular importance to companies where they have their sales data and they would like to create, let's say, interventions as far as their promotions is concerned, marketing budget. So they would need to forecast what would be their sales in the next X number of periods. So that's important for businesses. That's important even for, let's say, government agencies, for uh, planners. For example, the government would want to project the population in the next few years. What do they do? They use certain models in order to project what will be the population in the next, let's say, 10 years. And then based on this forecast, what do they need to do in order to for their plans as far as, let's say, number of hospitals, number of classrooms. So these are very uh, practical uh, decision-making concerns that government has, and forecasting plays a major role in that. And in order to forecast, it's important to understand the patterns and the seasonality in the data. A company that engages in a business, in, let's say, chocolates or flowers, will note that their sales normally tend to go up during February, before Valentine's or post Valentine's, or even during November. Okay, companies that engage in the flower business would see that these during this time, their sales tend to go up because of heightened demand. For school supplies, usually it's before the beginning of the school year. For Christmas decors, we know that 2 months before Christmas or during December, demand for Christmas decors go up. Okay, so these are things that are very important for a business as they consider patterns and seasonality in the data. Okay, and sometimes time series analysis is used to establish relationships between time series data. For example, a government would want to project or to forecast their GNP, GDP based on certain parameters. It can be inflation rate, okay? It can be population. It can be, let's say, uh, what else? Money exchange rate, money supply. So these are factors that can be associated with GNP, GDP, and models can be can be created in order to forecast or in order to better understand uh, these variables. Okay, so the result of being able to forecast, of being able to understand the behavior of the time series, results in better resource allocation and even risk management. Okay, so for generally, time series can either be univariate or multivariate. Okay, for univariate time series, we're only looking at one time series and modeling that time series using its past data. Okay, so we're not using other data in order to come up with a model for our time series. We're just using the past values of the time series. So that's called your univariate because there's only one variable, univariate time series. And one of the most popular method is ARIMA, autoregressive integrated moving average. Okay, we're going to use that. There are others like exponential smoothing. There's also this tool called Prophet, but the focus of this subject is on ARIMA, autoregressive integrated moving average, which we'll discuss by next week. Okay, and we not only model, let's say if you're looking at stock returns, we don't only model the stock returns itself, but also the behavior of the returns, its tendency to be erratic and go up when there are positive news and continue going up and go down when there are negative news and continue going down. So that's what we call volatility. And stock prices usually behave that way. They go up and then they keep on going up. So there, you'll see that there are uh, what we call volatility clustering. We'll illustrate that in the future. And then also it can go down and continue going down. So that's what we call volatility clustering. And ARIMA cannot solve that. So that's why there's a need for another method called GARCH. All right, for multivariate time series, what we can do is to try associate one time series with other variables. That's why it's called multivariate. So we have several models like VAR, which is vector autoregression, vector error correction model, Granger causality, and if we're looking at the volatility of several assets, then we do have what we call multivariate GARCH. Okay, so we might squeeze this in this subject. Okay, for those of you who were my students in FINSAR, maybe you'll find that this is quite a bit of a repetition. Yes, unfortunately, there's an overlap, but we'll try to differentiate it as much as we can. But the fundamentals are there. So if you were my students in time series before, then I hope this will be as a review for you to appreciate more the models that we learned last time. Plus, of course, other new stuff that we did not discuss before. So how do we analyze time series? There are several tools that we can do. Decompose it. Okay, what do we mean by decompose? So let me illustrate that. Let me annotate. By decomposition, what we mean is, so if your time series behaves this way, suppose this is your time series. All right. So number one, there seems to be a trend. Your time series seems to be going up. So what we can do is decompose this time series and get the trend. So we have this. Maybe get the seasonality, the ups going up, regular going ups. That's the seasonality. Okay. And do the unaccounted for data. So this is what we mean by decomposition. We split your time series into the trend, into its seasonality, and into an irregular component. That's what we mean by decomposition. Okay. Then we can also have smoothing. Smoothing plus means that we model the time series based on its past values. Let's say 30 days, okay? Past 30 days or past 45 days. We'll discuss this in greater detail. This smoothing, when we can take MA, moving averages, or ES, exponential smoothing. Okay. Then stationary test. We can also look at the data and check if it's stationary. Stationarity we're going to discuss later on, not today, but in the next lessons, because there is a need for us to make sure that the data is stationary before we can make use of the ARIMA model. Stationarity is more used for ARIMA model. I'll explain that in greater detail when we get to modeling time series itself. Then we have ACF and PACF, which is autocorrelation and partial autocorrelation analysis. Okay, we'll discuss that in greater detail. And then we can forecast, as I said, use ARIMA. And then after we have forecast our time series, we have to check if our forecast is good. So we will have to make use of several metrics like mean absolute error, root mean square error, mean absolute percentage error. These are metrics that assess the accuracy of our forecasts. Okay, so those are the tools that can be used. Clear all drawings, and then I'll exit. All right, so the first thing that we're going to do is we're going to, okay, let me open this. CC, which means class, you'll have to insert a code chunk. Okay, so if you recall, this shortcut for code chunk, instead of typing backticks and then curly brackets and then R, okay, and then close curly brackets, it's quite long. So the shortcut for code chunk is jet, depends on your computer. If you're using Mac, it's Command Option I. Okay. If you're using Windows, it's Control Alt I. I'm using Windows, Control Alt I. So there you go. Shortcut for your code chunk. Okay. And this one, we can erase this one, class, because that really has no meaning. Unless you want to put here a title. In the code chunk, let's put packages. So now it has a name here. So that's installing packages. Chunk one is setup, chunk two is packages. All right. Now the question is, how do we install packages? Okay, I'm going now to my file. Okay. How do we install packages? So let's first see, let's first, okay, install a very important package called Quant Mode. So how do we do that? So you go here to packages. Let's go to packages. And then type Quant Mode. Packages, and then here in the search button, called type Quant Mode. And is my screen not shared? Plus? Plus? Hello?
It's shared po.
Sorry?
The screen is shared po, sir.
Okay. Bakit ano? Bakit? Okay, I thought it was not shared. All right. So kindly chat, please, if you see under packages, search for Quant Mode. Please tell me if you have Quant Mode here in your packages. Okay, none. For those of you who were my students before, I'm sure you'll answer yes. Okay, because we installed it before. But for those of you who are new to R, most probably you don't have Quant Mode yet in your machine. Now, what's Quant Mode for? Okay, what's Quant Mode for? So let's install this first, and then let's see how what's the purpose of Quant Mode. So there are several ways to install a package. One way is to, under packages, you have this tab install. Okay, click this, and then write Quant Mode. Okay, and then make sure that installed in the dependencies is correct. Check. Okay, we'll not do that now. So that's one way to do it, and then install. Or you can go here to tools, same thing, but the access here is through tools. Here it's through packages. Tools, install packages. There. Same dialog box, type Quant Mode. Okay. And then install. All right. But we'll not install that through install or through the tools. What we're going to do is install the packages. So we have our code chunk. Now you notice that there's a hashtag here. Where are we? Where's that? Here. Okay, I'll put a name here, packages, to give it a name. Okay. So if you write, if you use the hashtag inside the code chunk, then this will be treated as a comment. It will not be treated as a, okay, as an outline. Okay, in my case, class, I don't have the CCs because I'm using the original file. Okay, in your case, there will be CCs there, which means that there are many outlines there. Let's say I'll go here. It's here. 2 hashtags. So that's why it's part of the outline. So every time we write the outline, you may just delete the CC there to make it to make your file better managed. Okay, so I'll go here. So whenever you see CC, make sure that it means that we're loading a code chunk. All right, so this is this is a comment. It will not appear here. So how do you install packages? We use the function install. So if I type install, you notice that R has an IntelliSense. It will now provide some functions that that start with install. So here, install that packages or install that packages. What we need is install that packages, and it's coming from the utils utils package. Okay, so I'll press tab here, tab, install that packages. Okay, install the packages, and then if you're installing only one, you have to put it in quotes, quant mode. Okay, or if you're installing more than one, you have to concatenate it, C, and then let's say TTR, let's install two. Okay, you can see now that I'm installing two packages. There's a red underline here, which means, and an X here, which means that there's something wrong with my code. Okay, what's wrong is that I didn't close the parentheses there. So once I close the parentheses, the X was removed, and also the underline. All right, so this is the way to install your packages. Install that packages, and then how do we run this? Anywhere in this line. As long as you're in this particular line, whether in the beginning or the middle or the end. And then, how do you run this? Control Enter. Control Enter. So there will be some messages here in your console. So it's now beginning to load it, install it. All right. And then you'll know that it's finished installing if you once again see this cursor here, this one. It means that you're ready for the next code. Okay, so here it tells us that installing packages, the message here is package TTR successfully unpacked, package quant mode successfully unpacked and checked. All right, now please tell me, those of you who said no a while ago, kindly check again your packages and tell me if there's quant mode already there. Please chat if the package quant mode is already there. Okay, good. Good. Okay, so let's first take a look at what quant mode is. If I click this, okay, in the help tab, okay, it will give us a comprehensive description of what the package is. If I click this, sorry, what's this all about? This is a package. The name is Quantitative Financial Modeling Framework. The version is 0.4.26. And to run, it needs the version of R that's higher than 3.2. So if your version of R is less than 3.2, then it will not run. It also needs XTS, the package XTS. Okay, so you'll notice if we check this class, okay, here, let me go back here to packages. Kindly check class XTS. Now, I bet you, class, that XTS was not there a while ago. But what happened? When you installed quant mode, it automatically installed the other packages for which it's dependent on. So quant mode depends on XTS, quant mode depends on TTR, So even if we didn't install XTS or TTR, it will still install those two packages together with it. Okay, so that's what I meant. So that's why there's XTS now here. Going back to quant mode. Okay, and let's go here to help. It was open a while ago here. Help. Okay, so you can take a look at the at some other help sources. If I go back, you can see now here that there are several functionalities here. So these are functions. Okay, you can tap this in order to access the output that can be generated from add BB. For example, this Bollinger Bands. If I click this, then it tells us that, okay, this is the function is add B bands. This is from quant mode, and it adds Bollinger Bands to your chart. Okay, so I'm not sure if you have taken Bollinger Bands in your in your other subjects. Okay, but it gives us this one, gives us an example. So this is the function add B bands n is equal to 20, etc., etc., etc. Okay, you can run this class, you can run this in your R, okay, but we're not going to do that now. And you'll have an output for that. Okay, for example, this one is not run. All right. Okay, so that's your that's your quant mode. We also installed ASTSA, so kindly check, please. ASTSA. ASTSA, so that's Applied Statistics for Time Series Analysis. This also contain several, let's check this first. ASTSA. And it contains several data, applied statistical time series. It's more than just data. It contains several functions, and it also contains several data. For example, this one, we're going to use this later on. I hope we're able to get here JJ. So this is Johnson and Johnson's quarterly earnings per share. So there are lots of data here, and not only data, but also function. Later on, we're going to access this and see what this data is all about. Okay, so back to packages. Now, can we now use, let's go back to quant mode. Can we now use the functionalities of quant mode? No, not yet. Why not, class? Because although the package is already available, okay, however, you need to load it in order to access it. Okay, so before we go to quant mode, I'd like you to type stats here. Stats. Stats. There. What do you notice about stats? You notice that stats is clicked. Okay, it's clicked. What does that mean? If I go to stats, you can see here what are the functions that are available with stats. You have ANOVA, analysis of variance AOB, okay, several. You have ARMA ACF, ARIMA function, ARIMA.simulation. Okay, so there are a lot of of functionalities that come with the ASTSA package. So the question again is, are we able to, sorry, I'm referring to stats. Are we able to access the stats functions? The answer is yes. Why yes? Because it's already checked. But did we write a code, command line to access stats? No, we did not. Because when you open RStudio, it's automatically loaded already. So you don't need to install stats. You don't need to load it because it's already preloaded. So there are other packages that are already preloaded, but not quant mode. Okay. quant mode was in fact not loaded, not installed. So we had to use installed packages. Okay. Now it's loaded. How can we make use of that? So to make use of a particular package, you either use library. Okay. So let's type library and then write quant mode there. You don't have to put it in parentheses. Okay. Or, okay, so let me comment this. Hashtag, you can make use of require quant mode. Okay, so you'll get the same result. Library quant mode or require quant mode. I'll just use library quant mode. So notice what happens when so make sure that your quant mode is already present, because you cannot use library if quant mode has not yet been installed. So here I'm using library in order to access, okay, in order to load, not install, but load quant mode. So tell me, class, what happens when you run library quant mode? I'll wait for your chat, please. Comment, please. What happens to uh, what happens to our quant mode when you load quant mode using library or okay? Thank you, Celine. How about the others? Okay, nag-check. Yeah, thank you. Yeah, it gets tick. You're correct. So when we use library, okay, control enter, notice that also my quant mode got checked. So getting checked means, class, that you're able now to make use of the functions coming from quant mode. Okay, otherwise, otherwise you won't be able to do that. Okay. All right. So uh, how do we install packages? So we use installed packages. If there's only one, you don't have to use C. If there are many packages that we're going to install, then make use of C. All right. Then there's another way to do it. Okay, but we need to install first a certain package. So let's use install, and this time let's use this one and load Pacman, package management. Okay, so kindly install that. I won't install it because I have that already. And then once you install it, kindly check your package if you have Pacman. Okay, in my case, I have it. Okay, please check if you were able to have Pacman already. Thank you. Okay, good. Good. Now, if you notice, loading required. Yeah, okay, my comment dito. What's this for? Kay Ralph, loading required package STS, zoo, and TTR. So this happened when you were loading quant mode. Okay, sige. I'll answer the question of Ralph. Okay, I'll pause share. Ralph, paki-share ng screen mo, please. Ralph? Okay, sige,
Sir,
sige.
may tapo na sa ibang device yung
Okay, it's okay. So, Ralph, kaya lumabas yung comment mo kanina. Okay. Kindly share your comment to everybody so everybody understands your question. Class, when you're asking question, please make sure you're not only directing it to me, unless it's a personal question. Please share it with everyone. Okay, there. So mine says loading required. So this will happen, class, if you're loading if you're loading quant mode, because these are dependencies of quant mode. Okay, so take note, when you load quant mode, there are other packages that will be loaded with it. Okay, in fact, we discussed that a while ago. We said that XTS will also be loaded because you need, ito na, sige. Yeah, okay, there, exactly. Just what Ralph was asking. So in this case, Ralph ran library quant mode. Ralph, could you please increase the font, please? So that others, I'm having difficulty seeing it also. Go to tools, please. Tools, tools, and then global options below. There. And then appearance, please. Appearance on the side there. And then maybe increase it to 18. 1.8. Masyado malaki yan. Also below. Okay. Thank you. Okay, please. All right, that's better. Okay, so please scroll down. So when Ralph ran this, it gave us this comment. Loading required package XTS zoo. Okay, attaching package zoo. Okay, go to packages, please, Ralph. And then type zoo. Zoo. And see, right? When Ralph loaded quant mode, and then nag-require ka ba, Ralph? And library required dyan, no? That's required. What happened? So quant mode became check, and so are the dependencies. Like zoo, go to TTR, please. TTR, okay, notice TTR, which is also a dependency of quant mode. We did not, yeah, we loaded that. Then it became check also. Ano pa? Zoo. How about XTS, please? XTS. There. So see, XTS is also checked. Why? Why is XTS already loaded? Because when you loaded quant mode using the library function, any package that it is dependent on will also become loaded. Okay, so that's the nature of loading packages in R. Okay. Did that answer your question? Okay. Ralph, mag-pacman ka na. Sa packages,
Sure, gets.
mag-pacman ka. So wala kang pacman, di ba? So go to install. There, just install it there, pacman. Okay, and then install. Okay. All right, so it's installing. Wait. There. You know that the command is run already when you see the greater than sign. So you have there pacman, right? It's already installed. Okay, don't click it yet. Don't click it yet. Okay, thank you, Ralph. Did that answer your question?
Yes, po, sir.
Okay.
Thank you po.
Okay. So I'll share screen again. Okay, sorry for my cold class. All right, let's go here. Another way to install packages is via the package called pacman. Okay. Now, I missed the opportunity for us not to install pacman because you can run this even if you haven't installed pacman. Okay, this will still run. Now, there's a function called pload. This is packages load, and it's coming from pacman. You notice how this is written? There's double colon here, colon, colon. And this indicates that this function comes from the package pacman. Okay? The function pload comes from the package pacman. Now take note here. I haven't loaded pacman. Now I said a while ago that you can only make use of the functionalities of a certain package if it's loaded. So if you have loaded it, right, like this, okay, library, kindly unclick it first. And that code is actually detach. Okay, detach. unload is equal to true. That's the command. That's equivalent command for unclicking your pacman. All right, I want you to type this pacman :pload and then let's load. Let's remove quant mode already because we have already loaded this. Remove quant mode. Remove TTR. We have already loaded this. So let's just maybe just ASTSA. We have already loaded it. Did we, class? No, we didn't include ASTSA. So just this one. Okay. So let's load ASTSA. Let's load tidyverse, tidyquant, and forecast. All right. Now I want you now make sure that pacman is unclicked because we'd like to see, will this run? By affixing the package pacman and then the double colon and then use p load, which is package load, will this run? And then what will happen? First, let's check. Do you have tidyquant there in your packages? Kindly check, please. Tidyquant. So most probably not. In my case, it's already there because I've already loaded this before. It is installed but not loaded. Okay, see, it's not checked. Now, can you please give me feedback if if okay, if class, if what was I asking you? Kindly check if you have tidyquant there. And please answer yes or no, please. Or even tidyverse. Okay, thank you. None. Okay, let's see. Now, pacman, we have pacman. We installed pacman a while ago, right? However, pacman is not clicked. We haven't required it. We haven't used library pacman. Now, the question is, will this command run? Pacman :pload. So again, this means that this function package load pload comes from the package pacman. So I said a while ago that if this is not checked, clicked, then you cannot access the functionalities of pacman. But if we affix the package here, pacman, and then double colon, then pload, let's see if this will install. Okay. You have tidyquant. In your case, there's no tidyquant there. So let's see. Kindly run this class and please give me a chat. What happened? Did this run? Did it install tidyquant or tidyverse? Okay, I'll wait for you, class, to and tell me, was tidyquant clicked or not? So those three things. Yes, if it installed tidyquant, and yes, if tidyquant is clicked, or yes, no, or no, no. So two questions. Was tidyquant installed and is tidyquant clicked? Go ahead, please. And I'll wait for your answer. If it's yes, yes, or yes, no, etc. No, no for Joyce. Okay. The others, please. Installed, not ticked. Okay, for Ralph. Na-install si tidyquant but not ticked. How about the others? Object pacman not found. Pag object pacman not found, ibig sabihin, you haven't installed it. You need to install it first, okay? No, no, it's not typing. Okay, make sure that you have pacman, okay? However, pacman is not clicked, no? Huwag nyo i-check si pacman, but it should be installed. Okay, how about the others? I'd like to see your answer. Okay. Bakit si Ralph? Yes, yes. Ralph, what did you do? Ralph, may we know what you did? Bakit naging yes, yes? Did you... Okay. Did you click Pacman? For the others, please kindly rerun. Make sure that Pacman is unclicked. And then pakirerun ulit yung payload na yan with Pacman. Okay. For Daniel, installed but not ticked. Okay. Si Tidic want daw na tick. Error. Anong error, James?
Sir, object Bachman not found pa rin.
O object Pacman not found. Which object? Pacman?
Yes po, sir. It's not reading the code po, sir.
But did you install Pacman already?
Yes po.
So naka-install na siya. Alright? So my point was, so medyo unstable class, no? Pag loaded si Pacman pero hindi naka-click. So let's do this. Why don't you click this? Click it. Okay. And then let me go to tidyquant, no? Tidyquant. So if tidyquant class, tidyquant, let's do this. Tidyquant is loaded here. I can now remove this package here. I'll remove it first here. Remove there. Are you sure you wish to temporarily, permanently uninstall tidyquant? Okay. It cannot be undone. Yes. So what I did was I uninstalled tidyquant. And the code for that is remove that packages tidyquant. So if you install it, install that packages. If you're going to remove it, remove that packages. So now I don't have tidyquant here. Okay. So let me go to my Pacman. Okay. So it's already loaded here. And let me run this. What will now happen if I install tidyquant and then load it through Pacman? Okay, let me run this, control enter. It's running. Okay, so here, tidyquant installed. Okay, what else? What else were installed? Okay, I already have tidyverse, so I did not install any more tidyverse because I have it. Okay. All right. If I take a look at tidyquant, okay, then let me this one refresh. Okay, there you go. So tidyquant was again installed. Okay, and then it's clicked. So my point here was if you use payload, it will automatically install a particular package and then at the same time already load it. That's why it's called package load. Okay, so two steps. It will do two steps: install and then load, which means that I can now make use of the tidyquant functions. If I check tidyverse class, tidyverse, my tidyverse is also checked or clicked. Can you check please your tidyverse? And also your AS, Applied Statistics, Time Series Analysis. Also my ASTSA, it's already clicked, loaded, installed, loaded. And my forecast, okay, also clicked. Okay. All right. So that's what happens if I use payload. So one step, it installs and then it loads. So this is one good shortcut instead of going to install the packages and library. This one is convenient. All right, let me pause for a while and feedback, please, if we're okay so far. Feedback, please. Any questions? Hello, class. Feedback, please, so that we can move forward. Let's not waste time by taking you a longer time to comment, please. If okay na kayo, class, please type okay. Thank you. Let's wait for the others. Okay, I saw a question. Let me just wait for the others to say okay. Okay, so there's a question here. Okay, Celine, kindly, sorry, I don't get your question. Paki-unmute na lang, please.
Uh, I just wanted to clarify if your point is there are many ways to install and check the
Yeah,
packages, but
okay.
what you want us to do or what you recommend us to do is the Pacman instead.
Yeah.
Okay,
So
thank
the
you.
regular way to do it is install that packages. And then once you have installed it, you have to use library or require, right? You can install it via the window box in the packages window you have installed, or use an R code install that packages. Okay, so another way to do it is to make sure that pacman is loaded and then use the pload function. Pacman pload, because the pload function will automatically install and load the packages in one go. Okay, so that's the only reason why I'm recommending it. But I'm not saying that it's more powerful. It's a bit faster, a lot faster, because instead of you doing installed packages and then doing library, you just use one p_load. And also, if you use installed packages, you'll have to use the quotes. Okay. Notice that in installed packages, if there are many packages that you want to install, you have to use letter C, concatenate, and then combine all those packages with the quotes. It will not run if there's no quotes. Okay. But when you use library, you don't have to use the quotes. Okay. But for pload, just write all the packages there. It will take care of the installation and the loading. Okay.
Thank you, sir.
Thank you. Okay. Thank you for that question. Okay. Good question. All right. I think there's another. Wait. Yes. That's why I recorded this. The recording will be uploaded. Okay, for you to be able to review it. Thank you, Chloe. All right. So let's now go here. Okay. Okay, good. We have plenty of time to start our time series discussion. Now let's go to, I think I showed you a while ago ASTSA. Let's look at ASTSA. Okay, here. If I click this, so this is a package that contains functionalities that we can use on about time series, and also like this autocorrelation function, autocorrelation function for multiple time series. Okay, bootstrapping. These are functions that we can use for time series. Okay, but there are also data sets here. For example, this one, birth, U.S. monthly live births. Okay, the one I said a while ago, CMORT, cardiovascular mortality from the LA population. JJ is data for Johnson & Johnson's quarterly earnings from 1960 to 19 1981, and there are many others. Okay, so what we're going to do now is make sure that our ASTA is loaded. How do we do that, class? How do we know that? Here, it has to be checked. Okay, it has to be loaded for us to be able to access the functions and the data coming from ASTSA. All right, so now let's go here now. So how do we access that data, JJ? So we make use of the function data JJ. So kindly run this, please. And let's see what happens if you create, please, another code chunk. And remove the CC there. Yeah, we can, here, sorry, we can give this a name. Our JJ data. Okay? Example, we can use that. It's good practice always to name your code chunk, or you can use just one contiguous text, JJ underscore data. It's up to you really. So when we run this, so if we run this class, it will run everything, all the code chunks inside it. We just want to run it line by line. Okay, so let's run this. Okay, what happened, class? What happened was you have here a JJ under your environment values, and then it says promise. It means that it's ready to load your data. So if we use the function JJ, or another way to run this is print JJ, okay, print JJ or JJ. So let's run JJ itself, because this is recognizable already because of the JJ here. Okay, this object has already been loaded, and if we type JJ, control enter, you'll notice that now, okay, in your console, it printed also the object JJ here, JJ, and it also showed the result here. But what's good with an R Markdown file is the result of your code is shown here also in your script file. So you have data from 1960 to 1981, 1980, I'm sorry. First quarter, second quarter, third quarter, fourth quarter. So this is definitely a time series. So it's data that is recorded on equally space in time. Okay, so quarter one, quarter two, quarter three, etc. From 1960 to 1980. All right. Now, it depends on the type of data. Okay. If you take a look at our environment here, notice that it's in values. Okay, we will analyze this more later when we have different types of data. Okay, but once again, I would like to remind you to please watch the videos. Okay, as the earlier you watch it, the better. Okay, do not watch it before the exams. Okay, that will be very difficult to do, and you won't be able to make it in the exams. So, if I may suggest, watch it now, and you may watch it again until such time that you have quite a good mastery of the topic, data types, and data structures. All right, so it tells us that this is a time series data. There are 84 observations from 1960 to 1981, and the values are 0.71, 0.63, etc. So this is what we call metadata. It's data about the data. Okay, so if we run view, what happens? View, control enter, and take a look at this view. Make sure it's capital V class, not small v. So it tells us that this is, okay, this is a, okay, JJ is the name, double class, double, 84 observations, S3, then time series. This is a type of object. Double class is a type of object. Okay. You have numerical data can be integer, okay, and it can be a number or double. Okay. It's called double because it allocates more memory or more space to these types of numbers because these numbers can take on decimal places. Unlike integers class, integers are not double. Okay, they're integers, and you don't allocate a bigger space for them because they do not take in decimals. Okay, they're counting numbers. Unlike this one, 0.71. So if your number is, if your data is numerical, in particular, a number, one that can take on decimal places, the type, that type of numerical data is called double. Okay, so that's what happens when you have view. Okay, let me just. I think we used the data before cars. Recall that class. So let's access that data pressure. Remember the pressure class, the pressure data that we used to plot. So let's run that data pressure, and you notice it's here. Okay, it was loaded here. And pressure is preloaded with R. That's why we were able to access it immediately. And then let's see view. View pressure. Okay. Let's view pressure. Okay. Now take note of this. Control Enter. All right. So there's a difference, class, between the view of JJ and the view of pressure. Okay. Take note here in the environment. Okay. For pressure, it formed part of data, but for JJ, it formed part of values. Now you'll be able to understand this once again if you view the data types and structures. This is under data structure. This one is called a data frame. Okay. This one is called a vector. Okay. So you have to know the distinction, class. Okay. Please. We're not going to discuss that in this class, but you have to know it on your own. And the video is available for you to watch. Okay. So you notice that there was a distinction between the pressure when it was recorded here in the environment window. It says 19 observations of 2 variables. And then when we viewed it, view pressure, it generated this one. Okay. You have this variable temperature and then this one pressure. On the other hand, when we viewed JJ, remember when we viewed this, it did not list to us in a columnar form the the data. It just gave some examples here. The difference is that JJ is a vector while pressure is a data frame. How do I know that? Let's go here. Okay. So what we did here, let me just, okay, just for me to recall, what we did here was to also do data pressure. Okay. And then we view pressure. That will remind me that we discussed this. And then another way to understand the data is to use this function structure, STR. STR stands for structure. So let's compare the structure of JJ. Okay. If I run this STR, there, it tells us that this is a time series. Okay. Time series. So this is a vector. A vector is an object in R which contains the same types of elements. So they're all numbers, all letters, all logical values, all imaginary numbers, all integers. So if they have the same elements, they're called vectors. So this is a vector because all of these are numbers, okay? 0.71, 0.63. This is what we call a time series vector. On the other hand, let's take a look at the structure of STR structure of pressure. Okay, structure of pressure. Let's see what happens here. Control Enter. All right, there you go. Okay, it tells us that pressure is a data frame. So it's not a time series vector, it's a data frame. And there's something important about a data frame class. So that's why I hope I've convinced you enough to spend some time. Okay. You don't watch it in one sitting. Okay. Allocate your time in your free time instead of doing things that may not be of value to you. Watch the video. Okay. And then understand what data types are and data structure. All right. So this is a type of a data structure and it's a data frame. A data frame can contain a combination of letters, logical values, characters, and numbers. Imagine class. Imagine, for example, if pressure has this other variable, let's say location, and location is, let's say, Quezon City, Manila, Baguio, etc. Then that variable location is not numeric, right? It's a character variable. So you can use that in your data frame. So a data frame is very powerful because it can contain numbers, it can contain integers, it can contain logical values, it can contain character values. It's a difference between a data frame and a vector. A vector can only contain one type of data, and the vector is not presented this way in a columnar, okay, in a rectangular data frame. A vector is just one line. Okay? Here, there, 0.71, 0.63, etc. All right, any questions so far, class? Kindly chat, please, if we're clear so far. Okay, good. Thank you. Please feel free to ask questions if you have any questions. All right, this lesson class types and class structures, data types and data structures is part of your online, no, face-to-face quiz. So make sure that you, as early as now, you spend some time reading it so that you don't cram. Okay. All right, so let's continue. Okay, so we were able to access the object JJ. Now, JJ, as we said, okay, so let's get the structure again. It's a time series, 84 observations. Okay, so that's quarterly, right? 4 times, how many years is this? 1960 to, so that's 21 years. 21 times 4, that's 84. Because there are 21 years and then quarterly data. So you have 84 observations. All right, now let's go here. Okay. R is very powerful as far as plotting is concerned. One of the most important, okay, let's take a look at this. Important package in R as far as data visualization is concerned is ggplot2. Okay, could you kindly type ggplot2 here? ggplot2. There you go. It should be clicked already because we loaded. This comes from tidyverse. So if you click, if you installed and loaded tidyverse, this is a dependency. So it will automatically also load ggplot2. So what does this mean, first, before we just plot a basic plot of JJ? Let's open this. And this is called the grammar of graphics, GG. So this is a powerful method to create plots and graphs. Okay? And there are many functions here. We're not going to study that now, but we're going to be exposed to this briefly, just some parts, because for me, I discussed this in FinStud. Okay, so we use also R in FinStud, and we have some weeks of discussing ggplot2. very powerful data visualization. Okay, so I want you to type this. We're going to use the plot function. Okay, plot comes from base R. Okay, and then we're going to plot JJ. This will be recognized because we have it here. And then type is equal to 0 or O, not 0. I'll explain what that means. And then Y label or Y lab, we call it Y lab, Y label, short for Y label. So we're going to give a label to our Y axis. And then let's call it J and J, Johnson & Johnson's quarterly earnings per share. Okay. All right, I'll give you a few minutes, a few seconds to run that code. Okay, and then once you run it, once you type the code and then run it, may I request you to please give me a feedback if you were able to do so. Thank you, Celine. Okay, good, Sheena. Thank you. Okay, Jana. Okay, good. Okay, thank you so much, class, for participating. I hope the others are also, please give me feedback. All right, good. I hope the others are able to follow. In case you have questions, please feel free, class. Okay. All right. Thank you. I'll now plot this, class. And you notice, as we have been discussing before, what's good about the R Markdown is that the plots are reproduced here in the script window, so that if we render this, it will become part of the document. Unlike if you were using an R script, where the plots will be placed here in the plots window. All right, so let's see how this looks. This is Johnson & Johnson's EPS, earnings per share. Now, the type there, you notice a circle here, okay? That's the type here, okay? The intersections. Okay, so you notice, class, that here. All right. So what do you notice about this? If we take a look at the components of this plot, okay, what can you say does this plot have? Does it have seasonality? Does it have seasonality? Yes, maybe partly, because there are some, when you say seasonality, regular ups and downs like this. So this is what will happen if you plot the time series of, let's say, of a store that is into a business that's into Christmas decors, for example. So it will pick up on November, December, okay, and then go down, because nobody really buys Christmas decors except for those bargain hunters. I know of some people who buy Christmas decors after Christmas, okay, and they store it in preparation for the next season. Okay, we have what we call, number one, there's the tendency, which we call T, or for trend. Seems that there is seasonality also, but not that much. Okay, so S, seasonality. Okay, and then there's this, sometimes we call it irregular. Okay, that which cannot be, that's not part of the trend, and that's not part of the seasonality, and we call it the irregular component. Okay, so that's this is what we can do with the time series. And okay, let me close this. Better illustration is, let's see if we can get data, and then let's see. This is also available, air passengers. Can you please type air passengers? This is also available. Control Enter. All right. So I now have here air passengers. Take a look at our environment there, their class. And it's also under values. Values. It means that this is not a data frame. If once again we take a look at, let's take view. View of, this is what we do. Okay. Better still, let's create an object class called AP there. Remember, this is the assignment operator. Okay. It's almost time class, but I have just a few seconds. I hope you don't mind. I'm creating this object AP, and it's to get the data for air passengers. We don't need to load any package because this is preloaded already. If I run this, okay, then I now have this. Okay. So no, we can't use. Sorry, wrong class. Sorry. I will have to load first air passengers. This one AP class, you notice that it's just a single value. It's just a character value. So let me go back to air passengers. Sorry about that. And then let's view this. View air passengers. There, you notice now that once we view it, it's now converted into, the promise is now updated into a time series. There. Control Enter. And just like JJ, which is just a time series, a vector, it will not print it just like a data frame. And let's quickly plot. Okay. Let me do it here and then I'll end here, class. We can now also plot air passengers. We can do this because we have already air passengers here, right? R already recognizes this object. Okay, Control Enter and take a look at the plot class. Okay, so next meeting we'll continue with this class. So this is the plot for air passengers. Where's that? Where did I put it? Here. Here. Sorry, napunta dun sa taas, no? Now, this has seasonal, this has trend. This also has seasonality. Okay. So next meeting, we're going to continue discussion of time series analysis. We haven't actually been modeling. We're just looking at, we will just look at more examples of this. All right. So let me stop recording now.